Hello, I'm going to be giving you some solutions to the Wits University Maths Competition 2019, and this video is looking at the ages from grade 8 and grade 9. I'm not going to repeat questions that have been covered in the previous age groups, so I have already written those down. If you have any questions on those, or if you'd like to see how those were done, feel free to look at the previous videos, but I'm going to start with question 2. Find the area of a circle with diameter 12 centimeters. Okay, so let's draw that. Here we've got a circle and the diameter is 12 centimeters. So D equals 12. That tells us that the radius is half of that, which is 6. And the area of a circle, you can either say that area is equal to pi r squared. It's also equal to pi d squared over 4. You can pick either of those. I just want to check I'm answering the right question. Yeah, okay. So if we go pi r squared, that one we're going to get pi times 6 squared. 6 squared is 36. So it's 36 pi. If we do it in this example, we're going to get pi times 12 squared is 144 over 4, and 144 over 4, let's see, 144 over 2 is 72 over 2 is 36. Yeah, it's going to give us the same answer, obviously, 36 pi. Okay, so the first answer, 36 pi, is 2. Sorry, it's B. Okay, let's jump to question 3. By what percentage does the area of a square increase if its side length increase by 25%? Okay, let's have a look at this. Again, let's draw it out. Okay, so let's say this is the square that we started with, and I'm going to, just so that I don't have to deal with the fractions, if the original side had a length of 100, okay, if it increases by 25%, we know that this is 25 and the total is 125. Okay, so so this is the original square, and the area here, let's write that down, that's 10,000. Okay, over here, this square has an area of 25 times 25, so let's write that down, 25 times 25, and let's actually just calculate that. I'm just going to do that with long multiplication. 25, 25, 5 times 25 is 125, 2 times 25 is 50, so that's 625. Okay, and this area is 25 times 100. That's easy. That is 2500, and there's another one over here, so that's 2500. So they want to know how much did the square increase by in terms of area. Is that the question? Let me just check. Okay, so let's quickly add all of this up. So in total, the increase in area is 2500 for that area, 2500 for that area, and then finally, well, let's add those up first. That equals 5,000. That's easy. plus 625, so that's let's just go 5, 6, 2, 5. That is the increase in area, and we want to express that as a percentage of the original value is 10,000. Okay, and it's easy to divide by 10,000. That is going to be naught. Let's take that away. So that equals 0.5625, which is 56.25%. That is the answer to this question, and that's in the list. That is option D. Okay, all of these other questions have already been answered previously, so I'm going to jump straight to question 11. Consider S equals 9 plus 99 plus 999 plus 99999, etc. up until, okay, so S equals 9 plus 99 plus 999 plus 9999 plus etc., etc. And we're going to stop at the number that's got 200, we're going to stop at the number that's got 2019 nines, which actually also means that there's 2000, let's write this here, so that's 2019 terms to this sum. Okay, let's obviously let's just see where this goes. Maybe we'll find a pattern. So let's look at the first number, 9. What happens if we add 99? 9 plus 99, that's 108. Okay, let's see what happens if we add 999 to that. Okay, so 8 plus 9 is 7, carry 1. 1 plus 9 is 0, carry 1. And eventually we're going to get 1 plus the carry is 2 plus 9 is 11. There we go. And well, already there is a little bit of a pattern. We want to know the sum of the digits. So in this case, the sum of the digits is 9. And here it's 9 again, and here it's 9 again. So if we repeat this, let's see, 9, 9, 9, 9, and let's add that up. 7 plus 9 is, let's just, sorry, 7 plus 9 is 16, carry 1, so 1 plus 9 is 0, carry 1. 1 plus 9 plus 1 is 11, so it's 1 carry 1, 1 plus 9 plus 1 is again 11. And same thing. So you can see this pattern. What we're going to keep going down here until we get, so let's go 1, 0, 1, 1, 1, 1, and then this is going to add up to 9 again. 1, 1, 2, 3, 4, 5, 7, 8, 9. Okay, and then if we add 9s again to that, we're going to get 9 plus 1 is 0. Carry 1. 1 plus 9 is again 0. Carry 1. 1 plus 1 plus 9 is 1, and that pattern is going to repeat. And we're going to have a total of 9 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so in total there were 10. Okay, so that's the first 10 numbers in the sequence. Should we see what happens at 11? Okay, so for the 11th one, we're going to have 11 nines. So let's draw it out fully. 9, 9, 9, 9, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Sorry, 10, 11 plus 1, 1, 1, 1, 1, 1, 0, 0. Okay, so here the sum is 99. 9 plus 1 is 0. And then carry 1, sorry. So here we're going to get all of those ones again. And this total length is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So we've got 9. This adds up. The digits in this case are going to add up to 27. Okay, and well, let's see what happens if we go to the next digit. So we're going to have this plus 9, 9, 9, 9, 9, 9, 9, 9, 9, 9. Let's see where we end up. 9 plus 9 is 8, carry 1 is 9. 9 plus 9 plus the carry is 9, carry again. It's going to be a 0. Because of the carry, so the carry plus 0 plus 9 is 0, carry 1, and again this is going to now repeat the pattern. So the number is 1 digit longer, we one less over here, so again this adds up to 27. But let's have a look at this pattern. Every time that we add the next number, okay, every time that we add the next number, we make this number 1 digit longer, and in this case we're counting down from 99. We're going to count down from 99 down to 0. So eventually this pattern is going to be 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, a whole lot of ones, and then it's going to be 0, 0, 0. Okay, and yeah, okay, so let's see how this pattern, I'm going to erase this, let's see where the pattern goes. Okay, so the first number we had was 9. The second number that we had was 108, 107 up to, sorry, 1107, 111, so a whole lot of ones. Let's not count those for now. 0, 0, and that we've got the first 10 numbers. Then we're going to go a whole lot of ones, 0, 99, and we're going to take that down to a whole lot of ones, 0, 0, 0, and in this we've got 100. There's 100 numbers in this list. The pattern then goes to a whole lot of ones in front, 0, 9, 9, 9, up until 1, 1, a whole lot of ones. I'm not going to count the ones, we'll count that at the end. 0, 0, 0, 0. And here we've got 1,000. 1,000 numbers. So we still, so 10 plus 100 plus 1,000, it's still less than 2,000. So let's look at the next part of the pattern. It's going to be 1, 1, 1, 1, 1, 1, a whole lot of ones, 0, 9, 9, 9, 9. And that's going to eventually work down to a whole lot of ones, 0, 0, 0, 0, 0. And here there are 10,000 numbers, and the pattern obviously does continue. But we know that the final answer is going to be somewhere in this region. Okay, so let's see exactly where we're going to end up. This is, which element is this? So that's the 10th element. This is the, so I'm just going to write 10. This one is 110, because there's 10 plus 100, and this one is 1, 1, 1, 0. Okay, so we know that the first element here is 1, 1, 1, 1. Okay, how many more do we need to take? So if we say 2, 0, 1, 9 minus 1, 1, 1, 1, what do we end up? That's 8. Sorry, 1 minus 1 is 0, and then 20 minus 11 is 9. So we need another 908 elements down. Okay, so we want to go down 908 times. So let's see where we end up. Every time we drop down, we are going to subtract 1 from this. So let's do that. 9, 9, 9, 9 minus 908. What do we get? 9 minus 8 is 1. 9 minus 0 is 9. 9 minus 9 is 0. And 9 there. Okay, so the number, the sum that we are going to end up with eventually. Okay, let's, I'm going to fill it in here. The sum that we are eventually going to end up with is a whole lot of ones, okay, plus it ends in 0, 9, 0, 9, 1. So that is the final answer that we have got. But how many ones are in front? So that's basically the last part of this puzzle. We know that the length of the number, the number of ones is always equal to whatever. So in other words, the first element has got 0 ones. The second element has got, the second element has got 1 1. The third element, or the third partial sum, let's call it that, has got 2 ones. So we want to know the sum for the 2019th element. So that means that this, sorry, actually I'm not talking 100% true. Sorry, apologies. So what I'm saying is not actually true. We know that the length of the number, okay, except for this first one, that's maybe an exception. The length of the number is always 1 more than, so here we added 99 and we got a 3-digit number. Here we added a 3-digit number and we got a 4-digit number. So here we're adding, the last term is going to have 2019 ones, 2019 digits. So the length of this whole number is 2020. So it's 2019 plus 1. So 5 of them are not ones. So that means that here we've got 2015. So let's make some space on this board. I'm going to erase this. I don't think we need that anymore. The final sum, we're going to say S is equal to 1, 1, 1, 1, 1, 1, 1, 1, 1. In total here, we've got 2015, and then it ends in 0, 9, 0, 9, 1. And if we add this up, 18, this is 19. So this adds up to 19. And therefore our final solution is, okay, so S is the number, but we want the sum of the digits. So the sum of these digits is, I'm just going to write S prime is equal to 2015, because that's how many ones there are, plus 19, which is equal to 2034. Let's check if that's one of our solutions. 2034 is option B. Okay, next question. How many squares are there in the following picture? Include squares which are not 1 by 1. Okay. Okay, that previous question was a bit of a beast actually. Okay, anyway, question 12. We've got a 3 by 3 grid. Okay, so let's look at the first option. How many squares are 1 by 1? 1 by 1. Okay, we can have 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, how many squares are 2 by 2? Okay, so here, okay, let's just maybe look at the bottom right corner, for instance. So if the bottom right corner is there, then our square doesn't fit. So in this case, we only are able to count those 4. So this point represents that square, this point represents that square, this point represents that square, and there we go, etc., etc. So going back to that, the 2 by 2 squares, we've got 4. And then the 3 by 3, there's only one option to do a 3 by 3 square. So 9 plus 4 plus 1 is 14. Let's see, okay, so option D is 14. Okay, let's look at the next question. In triangle ACE below, F lies on AE, D lies on CE, B lies on AC, and AF equals AB, and EF equals ED, and angle ACE is 80 degrees. Calculate the angle marked X. Okay, so let's draw that. So we've got a triangle like that. I'm not going to draw this to scale. Let's see where we end up. Okay, B, F, okay, so let's say A. Okay, so they've said that these and those sides are equal because, Let me finish drawing it first. That's A, B, C, D, E, F. And they have said AF equals AB, so AF equals AB. And they have said DE equals EF, EF equals ED. Okay, so we've said that as well, and we know that angle ACE is 80 degrees. ACE, so this angle here is 80 degrees. Calculate the marked angle X. So they want to know, what is that angle there, X. Okie dokes. So let's call this angle here Y. Okay, so we know that Y plus Y, and I'm just going to call this, let's call this angle E to match that corner label. So Y, 2Y plus E equals 180 degrees. We know that these are both equal angles because it's a isosceles triangle. Okay, we can do a similar thing for here. I'm just going to call that angle A, and therefore what have we got? I'm just going to make that a Z. Okay, so we've got 2Z plus A equals 180. And let's see if we can get some other equations. Well, let's see, what do we want here? X plus Y plus Z equals 180. So just quickly to fill you in, here I'm looking at the angles of a triangle. Similarly, I'm doing the same here. Because these are both isosceles triangles, the angles opposite the equal sides must be the same, and the angles of a triangle add up to 180 degrees. And then here I'm looking at the angles on a straight line. X plus Y plus Z is also equal to 180 degrees. Okay, so maybe we can already see what we can do here. Here we've got X plus Y plus Z is 180 degrees. Here we've got 2y and 2z, so let's just multiply this equation by 2. So 2x plus 2y plus 2z is equal to 180 degrees. I'm going to take this to the other side, so that tells me 2y is equal to 180 minus e, and here we've got 2z equals 180 minus a. And let's write that in here. Sorry, this is 360. 2x plus 2y plus 2z equals 360. Let's substitute these in here. We've got 2x plus, now 2y we've said is 180 minus e. 2z is 180 minus a. And that equals 360. So let's add all of this up. 2x plus 360 minus a minus e equals 360. The 360s can cancel out. Let's take the a and the e to the other side. 2x is equal to a plus e. Okay, 2x is equal to a plus e. But we also know we've got one last option. A plus e plus 80 is equal to 180 degrees. And again, so this is looking at the sum of angles in a triangle, but this is now the big outer triangle. So A plus E is equal to 100. So 2x is equal to 100, and therefore x is equal to 50 degrees. And 50 degrees is the answer D. Okay. Apologies for the break, the battery on the camera died. So anyway, I'm going to carry on from question 14. So the question says, this exam consists of 3 sections, each with 5 questions. The questions in those sections are worth respectively 3, 4, and 5 points. With the 5th highest score, what is the 5th highest score possible to achieve? Okay, so there's a bit of a wording error on the question, but anyways, they want to know the 5th highest score that's possible. So section A is worth 3 points, section B is worth 4 points, section C is worth 5 points, and there's 5 questions in each. Okay, so that's 15, 20, and 25, and this gives us a total of 60 points is full marks. Obviously the highest score possible is going to be full marks. Okay, it's impossible to get 59 or 58 because none of the questions are worth either 1 or 2 points, but it is possible to get 57 by getting that one wrong, 56 by getting the 4-point question wrong, and 55. And we can also get 54 points if we get 2 of the easy questions wrong. So let's say, there we go, 54. So that's 1, 2, 3, 4, 5. The 5th highest possible score is 54 points. And that is, where are we? Okay, and that is the answer A. Okay, let's go to the last question. Find the last digit of 2 to the power 2019 plus 3 to the power 2019 plus 5 to the power 2019. Okay, so let's have a look. Okay, so they want us to find the last digit of this sum. Obviously, they're not asking us to calculate the number. That's going to be a really big number. But it's quite easy to calculate the last digit. This is something that you must just remember. I'm sure that you're going to get other questions like this in the future. But 2 to the power 2019. Let's look at the 2 times table. So we've got 2, 4. It's not the 2 times table. That's powers of 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. We don't really care about this digit because if anything that ends with a 6, if you multiply that by 2 again, you're going to end up with a 2. So you can see that this pattern repeats 2, 4, 8, 6, 2, 4, 8, 6, 2, 4, 8, 6. And okay, so this is 2. let's do something similar with 3. We've got 3. 3 times 3 is 9. 9 times 3 is 27. 7 times 3 is 21. And 1 times 3 is 3. And then that pattern will again continue. And 5, we've got 5. 5 times 5 is 25. 5 times, or 25 times 5 is 125. But all of these are going to end in a 5. So this is going to be to the power 1. Okay. So if it was 2 to the power 1 plus 3 to the power 1 plus 5 to the power 1, we would end up with this number. You can see that both of these are going to repeat in a cycle of 4. So after 4 steps you go back to the beginning, and similarly over here. After 4 steps you go back to the beginning. Here you repeat every 1, but you know, it's going to make it simple to just say, again, everything is repeating in the same pattern. After 4 steps you go back to the beginning. So 1, 2, 3, 4. And then you go back to the beginning again with 5, so that's 1 or 5, 2 or 6, 3 or 7, etc., etc., 4 or 8. So you can see that if you end up with if the exponent is a power of 4, or is a multiple of 4, then this is going to be our final answer, is going to be 6 plus 1 plus 5. But 2019 is not a multiple of 4, it's 1 less than a multiple of 4. So we are going to end up in this row. And what have we got? 8 plus 7 plus 5. Those are the last digits. And that is equal to 8 and 5 is 13 plus 7 is 0. Right. So I say that, okay, so this actually equals 20, but the last digit is a 0, and therefore the answer is A. The last digit of this number is a 0. Okay, thank you. That's the end of the grade 8 and 9 paper. Thank you.